for this lesson, you will require a graphing calculator. Um, Things we'll be using in this unit are our buttons, stat buttons, okay? Um, and we'll be inputting list. So we'll be going to the menu for edit. And but first we will start off with scatter plots. So we'll talk about scatter plots. So a scatter plot is it's like a bunch of data. So it's a collection of data. Things we can think about as being useful for scatter plots or used by scatter plots. Um, Baseball statistics, number of hits versus number of outs, things like that. Number of hits versus the amount of fans that you have. And basically what you do with scatter plot, much like linear equations and other equations, is you make predictions about what could happen. So basically, if some baseball player increases the amount of hits that he or she makes, then we can probably predict that if there's a pattern of showing that as the hits increase, that the number of fans increase. We could make a prediction, and we could pinpoint almost to the point, make either very good predictions or very bad predictions based on previous history, where if the number of hits increases, then we can say that the number of fans will increase as that continues to happen. So scatter plots is just a bunch of data to make predictions. So we have something called a line of best fit. It's an equation. It might also be the curve of best fit, and it's a trend line. It's basically what I was just talking about. It enables you to make predictions, and this line may pass through some of the points, or none of the points, or all of the points. So below, we're going to use this graph, and we're going to like create our own little trend line going through there. So basically, the trend line is the line of best fit. It's got to fit. It's got to make a path of prediction across the data that's there. So that means it's going to be going right through the center of all that data, and my trend line looks like it's going to be right about here, going through the data. And if I'm going to make predictions, I can say when I have, let's see. So when I have 100 followers, I also have 100 followings. Okay, so this scatter plot is about the number of followers versus the number of followings. So is the slope of best fit line positive or negative? So is this slope positive or negative? It's going uphill, so it's positive. It's positive. And does the number of followers increase or decrease when you are following a high number of people? Looks like it's increasing. Followers are increasing as followings increase. Give an estimate of the possible number of followers if you are following 100 people. So already did this. We have 100, 100, about 100 approximately. And we want to use an approximate symbol here. The person with the second highest number of followers is following how many people? Second highest number of followers. Second highest number of followers. Looks like this is the second highest number. And we're right below 1,000. It's in increments of 100, so probably about 900 of those are following. 900. Okay? So next we're going to talk about correlation coefficients. And you kind of heard me say the word prediction. So the correlation coefficient, it quantifies and describes how much one variable affects another, or basically how well you can make predictions. about a set of data? How well can I make predictions about a set of data? And it's just a number between -1 and 1. And if the closer this number gets to -1, or the closer it gets to 1, the line is a line of best fit. It's a very good curve. I can make good predictions. Here I make good predictions, very good predictions. Bad predictions occur here, or most likely to occur here, okay? And then good predictions can occur here. So if it's curved uphill, I know that my correlation coefficient is positive. If it's curved downhill, I know that it's negative. And if that data is scattered, these points are all over the place, we're making bad predictions. And we don't want to do that. So we want to probably reassess. If you're in the area of statistics, you want to reassess what kind of data you're gathering, and maybe gather some new data so you can make predictions to get the results that you want. This correlation coefficient is represented by the letter R. What do you think the correlation coefficient is for a number of followers and followings of users? It looks very close to 1. It looks very close to 1 on the previous page. So keeping what I said in mind, steep curves, very clear patterns, not necessarily steep, but the trend is very predictable. Like I could tell there's a pattern of what's next. It's going to be close to 1 or -1, depending on if it's downhill or not. So this is what I'm going to do for the next part. So we're going to match each correlation coefficient with one of the data sets graphed. So what we're going to do is figure out whether the graph is displaying a negative or a positive, or in between. So 15 is negative, 16 positive, 17 positive, 18 negative, 19 question mark, 20 question mark positive, and 20 negative. All right. So very steep curve, very predictable curve. 15 looks like very predictable. 17 looks very predictable. So if it's downhill, this correlation coefficient is -1. If it's uphill and it's very predictable, it's R equals 1. Now, that eliminates this choice and this choice at that point. We have 2 more negatives, so we want to choose the one that's very predictable for the highest negative, or the lowest negative actually. And this correlation coefficient will be -0.91. It's very predictable. This is more predictable than, say, number 18, which has a lesser or a greater, if you're thinking about negatives, correlation coefficient. Now, 1916, 19 is less predictable, so it's going to be lower. So R equals 0.63. On the other hand, for 16, R equals 0.87 because it's more predictable. The pattern is predictable. Now, for the next part, we're going to use data in the table to graph scatter plots and make predictions. So we're going to be using the stat function in our calculators, and we're going to go to Edit, and we're going to input these numbers. And so when we put these in, this is data for a number of assault crimes committed in one Midwestern town. We're going to get the equation for the line of best fit. We're also going to create a scatter plot. So I'm going to go ahead and set this up here, create a scatter plot. And this is good practice because we tend to rely too much on our calculators. So we're going to need about base years to time. Time is on the bottom. So years, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tick marks. Now, this is years. This is years. Years. Okay. And I'm going to label. So they said let 0 represent 2006. So this is 0, 1, 2, 3, 4, 5, 6, your 7, 8, 9. Okay, so here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, need 10 tick marks going up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have points. Let's see, we're between points. We're just going to go all the way up to 0.50 and 2, 4, 6, 8, 10. So 0.32, 0.34, 0.36, 0.38, 0.40, 0.42, 0.44, 0.46, 0.48, and 0.50. So basically what I did is I started at 0.30 and went up by increments of 0.02 for each set of data to make it fit. So I'm going to graph this data. I'm going to graph it, and I'm going to make the dots, I guess I can make them yellow or orange. Orange is better. Okay, so let's go ahead and get started here. So at 0, I have 0.39. So up here at right below here, I have 0.39. Let's make those green so we can see them. 0.39. At 1, I have 0.41 right above in the middle. At 2, I have 0.42 right here. At 3, 0.44. At 4, 0.44. At 5, 0.44. At 6, 0.45. 7.46, 8.49, and we can kind of see a trend going upwards. Trend is going upwards. So our line of best fit, it's going to come right through the center of all that data. It's going to look something like that. That's a line of best fit. Now we can be more exact and get an equation. So that's when we go to our graphing calculator. I'm going to go to our graphing calculator, input those numbers. So we've got to stat, edit, put those numbers in. Okay, so hold on. Okay, so I have my numbers in, and after that, I'm going to go to stats, back to stat, right arrow over to calc, and down to linear regression for that line of best fit. I'm going to make sure my X list says list 1. My Y list says list 2. I'm going to go down to store regular equation, press alpha trace, and hit enter for y equals, and go down to calculate and press enter, and I get y equals ax plus b, a equals 0.01. So when I'm writing down this equation, it's going to look like this. The equation is going to be y equals 0.01 times x plus my b, which is 0.39. Okay, now the correlation coefficient, we can get that if we go back and press second catalog. Make sure this is the right one. No, second mode. So if we go over to mode, go down to stat diagnostics and turn them on, press enter, second mode, and then we'll press enter again, and our R coefficient should show up, and it's 0.969. It's very close to 1. It's very close to 1. R equals 0.969. It's very close to 1. That data, it's saying that data is very predictable. So does this data represent a positive, negative, or no correlation? It's a positive correlation. because the number is positive, the R number is positive. And next it says predict the number of assault crimes committed in 2020. So 2020, keep in mind x equals 0 here. So that's 14 more years. So when x equals 14, what does y equal? Y equals, you can either just plug it into the formula this way, plus 0.39, or you can use your calculator. I prefer to go to my calculator. I already had you store this formula. We're going to practice that in a different part of this lesson. But we already stored it, and we go to second graph, and I'm going to go up down to where x equals 14 to stand for 2020. And we're looking at a statistic of 0.5403. Y equals 0.5403 in about 14 years. The data for 1975 and 85 were destroyed in a fire. Estimate the number of assault crimes committed in 1978 and in 1985. So 2006 minus 78 minus 78. We want to get how many years ago that was, and then 2006 minus 85 to get the number of years ago that we're looking at for these crimes. So I'm going to second mode, see 2006 minus 78, 28 years, or you could have done 1978. But 28 years, so we go back, it's going to be negative 28 since we went backwards. I'm going to go up to negative 28 and see what the statistic was then. It says that it's lower. It says it's very much lower. The statistic is 0.11 for 1978. So 0.11 for 1978. How about an 85, which was only 21 years later, so at negative 21, 0.18. That's the rate of the crime. That's the rate of assaults. Okay. So for the next one, we're doing a scatter plot based on the population of Arizona. So I can go ahead and make my scatter plot here. And actually this time I'm going to show you how to do it on the graph and just copy it over. So we're just going to go ahead and input this information. Let's do it correctly. It says let x equal 0 represent 1970. So here's 0. This is 1. Just mark all of these out. We're not going to put these numbers, these years in. It's too much to do on the graphing calculator. It just makes more sense in this way when we're working with years and time to change those to each year. It's easier to use the information. So I go to my graphing calculator. I'm going to go back to Stat and press Edit, and then I want to clear out each list. The way you do this, you press Up, Clear, Enter, and then go up to List 1, Up, Clear, Enter. So I'm going to keep that list in there because I need those 9 digits, and just go ahead and input list number 2. And so I have 1509, 2141, 2529, 2813, 2768, 2962, 3005, 3057, 3215, and 3266. Okay, have my information in, so I'm going to get my line of best fit. I go to Stat, right arrow over to Calc, go down to number 4 for linear regression. I'm going to store this into my Y1 alpha trace, enter Y1, and I'm going to go down to calculate and press enter. And I have my R value. It's lower than the last time, so it's a little bit less predictable than my last scatter plot. I want to trace this plot, so I'm going to go to y equals, go up to plot, and you can see that your equation is in there already. Go up to plot, and then we're going to press second stat plot, press enter, enter, and press trace. And we want to zoom, we want to go to zoom stat. Zoom stat. And if you look, there's our curve. And my line of best fit is that straight line going through it. So I'm going to just snag this picture, copy it over, and okay. So I snagged the picture, copy it over, and let's just put it in a scatter plot. Yours is going to be a little bit different because you have to actually do it. But line of best fit here, we have, I'm going to go back to y equals to get my line of best fit. I have 162.07 x plus 1997.2. So line of best fit, y equals 162.07 x plus 1997.2. How closely does the line seem to fit to the data? It's relatively close. It's close. It's close. What is the correlation coefficient? R equals 0.9, okay? 90. What does it indicate about the data? It indicates the closer that it gets to 1, it is very predictable. It is predictable. The data allows for predictions. Okay? So for practice, you're going to work on the next table. You're going to get the equation of line of best fit, write the equation of line of best fit, and I will work with you guys through that process. And this is the next page is just like it allows you to read the directions for how to create scatter plots, find the line of best fit, delete data, how to turn on diagnostics so you can see your correlation coefficient, and you should be working on the review after that. So go ahead and do those last problems, and just touch base with me afterwards. All right, so you guys have a good day. That's the lesson 3, scatter plots.